Sorry for my numbering. Number 6, there are 102 cats in an animal shelter, and of those cats, 65 like to play with catnip, and 43 like to play with a laser pen. If 36 cats like to play with both catnip and a laser pen, what is the probability that you will adopt a cat with either likes catnip or a laser pen? Sorry about that. My English is a little bit not good in the problem when I'm reading it out loud. But watch out for this word or, because again, on the front of the page, we've got our probability addition rule. That's what we want to use. So let's set it up. It's the probability that they like catnip plus the probability that they like to play with a laser pen, and then we have to take out the probability of the catnip and the laser pen, and what that gives us is our or. So the probability that they like to play with catnip is 65 out of a total of 102. 43 like to play with a laser pen out of 102, and then 36 like to play with both. So there's the overlap that we have to take out to get this. And once again, when we go to Desmos, we go to our calculator. We don't have to type in the whole fraction. We can do 65 plus 43 minus 36, and we get 72 out of 102. Same idea here on problem number 7. At a particular school with 200 male students, 58 play football, 40 play basketball, 8 play both football and basketball. Find the probability that a randomly selected male student plays basketball or football. So there's that or again. That means that we have to use the probability addition rule. So it's the probability that a student plays football plus the probability that the student plays basketball minus the probability that they play football and basketball. And that's going to give us our or. And I'd like to write that out just because of some of the a little bit more challenging problems that we work with here. But 58 out of a total of 200 play football. 40 out of a total of 200 play basketball. 8 play both. And then we can pull up our calculator or Desmos. And this time we've got 58 plus 40 minus 8 equals 90 out of 200. And again, just a reminder that sometimes the OST likes to have a decimal value, so this would be 0.45. I usually stick with the fractions. Same thing here on problem number 8. In a recent independent study, it was found that 63% of all students at Mill University read Time magazine, 51% read U.S. News and World Report, and 24% read both magazines. If a student at Mill University is randomly selected, what is the probability that the student reads either magazine? So either is an or concept there, so we've got to watch out for words that mean or. And as we set this up here, this time we've got the probability that they read Time, the probability that they read U.S. News and World Report, probability of Time and the U.S. News and World Report, and that's going to equal our or. So when we set this up, the probability, let's see, read Time, let's see, 63 read Time, and again I know it's a percentage, so I'm just going to write the 63. 51 read the U.S. News and World Report. We can take out all of those overlap, so 63 plus 51 minus 24 gives us 90 And then I'm just going to put the percent back in.